In this section, we're going to take a look at three main concepts. So we're taking a look, first of all, at two formulas. So we're going to take a look at distance and midpoint formulas. And then once we have a good understanding of those, the next thing we're going to take a look at is the equations of circles. And we're going to be learning how we can plot the equations of circles, some of the properties of the equations, but then also how we can formulate those equations given some conditions. And we are going to have to use the midpoint and distance formulas for some of those. So first thing we're going to do is we are going to take a look at the distance between 2 points on a Cartesian plane. We're going to use our formula. Then we're going to find the midpoint of the line segment formed by 2 points on a Cartesian plane. So these two are going to be in our first video. And then the rest of the videos are going to focus on equations of circles and then being able to find the properties of circles, such as the center, radius, domain, and range of a circle if we're given the equation of a circle. And sometimes we're going to have to put it in that form. So two formulas, and these should be two formulas that you have on your formula card. The first of all is the distance formula. So let's say we have a point x1, y1, and another point x2, y2 on a Cartesian plane. Well, we can find the distance by squaring the difference in the x coordinates and the difference in the y coordinates, adding those squares together, and then taking the square root, right? And then if we want to try to find the midpoint, essentially what we're going to do is we're going to add the x coordinates, divide by 2, add the y coordinates, divide by 2. Okay, so again, these two formulas are going to be formulas that we should have on our formula card, so that way we make sure that we're able to compute those if necessary. So let's take a look at some examples of being able to find midpoint and distance of 2 points. So we want to find the exact distance between 2 points, and then we're going to find the approximate distance accurate to 2 decimal places, and then we're going to find the midpoint of the line segment. All right, so first one, let's find the distance. And one thing that we can do is we can start by labeling the points. So this first point, I'm going to call x1 and then y1, and then I can call this one x2, y2. All right, and so all I'm going to do is I'm just going to substitute immediately into our distance formula. And so our distance d is going to be equal to the square root of 5, which is x2 minus x1, so that's 5 minus 10 square, plus 0 minus 12 square. Now, when we go through and evaluate, remember we always take care of what's in parentheses first. So that's going to be the square root of negative 5 squared plus negative 12 squared. Or that's the square root of 25 plus 144. Or that's the square root of 169. And then finally, we would just take the square root of that, and we could either just use our calculator, or maybe we just know that the square root is going to be 13. All right, so for this one, it is the exact distance, and then there's no reason to approximate it, all right, just because it's exact anyway. Now, to find the midpoint, all we're going to do is we're just going to employ this formula, x1 plus x2, y1 plus y2, and then we're going to divide those by 2. So for our midpoint, that's going to be equal to 10 plus 5 divided by 2, comma, 0 plus 12 divided by 2. Okay? Or 12 plus 0 if we are going in the order presented. So we just make sure we're exact with this. Although we know addition's commutative, it doesn't matter, but since the formula is y1 plus y2, I'll just stick to that. That's going to give us 15 halves, comma, 12 halves, or we could just write that as 15 halves, comma, 6. Okay, so that's going to be our exact value for both the distance as well as the midpoint. Okay, so that's not too difficult. Let's just take a look at some other examples of this. So again, what I'm going to do is I'm going to label this as x1, y1, and then x2, y2. All right, so these are our points that we're using. And so our distance formula d, remember x2 minus x1 squared under the square root. So that's going to be 8 minus 5 squared, and then plus negative 5 minus a minus 2. So that's negative 5 minus a minus 2 squared. Now, if we simplify that, that's going to be the square root of 3 squared plus negative 3 squared. Okay? Or that's going to be the square root of 9 plus 9, which is going to be the square root of 18. All right, now Unfortunately, we'd still have to simplify the square root of 18. And the reason we need to simplify it is because we know that 18 contains a common factor, a factor, excuse me, of a perfect square. So another way to write the square root of 18 is to write it as the square root of 9 times 2. And we know that 9 is a perfect square. 2 is not, but it doesn't matter. So that would be the square root of 9 times the square root of 2, or more simply 3 roots of 2, right? So anytime we give the exact distance, we want to make sure that we put that in the simplified form. Now, the other instruction is to be able to estimate that, or to approximate it accurate to 2 decimal places, okay? So we're just going to use a calculator for that, excuse me. So let me just go ahead and I'm going to use Desmos Scientific Calculator. And just give it a moment. I'm sorry for the delay. Right. Here's a scientific calculator. And it's probably easier for us, rather than typing in 3 roots of 2, we could just type in the square root of 18. All right. And if we do so, that's going to be 4.24. Okay. So if we write this up, that's going to be 4.24. But just making sure that we understand, if we wanted to type that in, we could as 3 roots of 2, 3 root 2. That's still the same exact thing. And that's a way to verify that you've gotten the correct answer, is that the unsimplified form and the simplified form should be the same thing, right? Now, let's also find the midpoint. And our midpoint is going to be 8 plus 5 divided by 2, comma, and then -5 plus -2. Okay, so again, what we're doing is we're just employing this formula. Okay, so x2 plus x1 over 2, and then we have our -2 plus -5 divided by 2. And again, I think just to make sure I'm going along with the formula, since it's x1, y2, or x2, x1, x2, just 5 plus 8 instead of 8 plus 5. Although again, it doesn't really matter. That's going to turn into 13 over 2, comma, -7 over 2. All right, so that's our midpoint. All right, nothing we can do to simplify that. All right, they're both exact values. All right. Another example, we have the square root, or negative root 37, comma 0, and then 0 root 35. All right, so distance formula D, and I know it looks a little bit ugly, but that's okay. It's not going to make it too bad. So we have, remember, x1, comma y1, and then x2, y2. And so we have x2 minus x1, so that's going to be 0 minus a negative root 37, plus root 35 minus 0 squared for both of those. Right? Now, if we go through and evaluate, that's going to be the square root of root 37 squared plus root 35 squared. And we know that a square and a square root undo each other, right? So this actually works out pretty nicely. So we have square root 37 plus 35. Okay? And then 37 plus 35 should be 72. All right, now, full disclosure, root 72 is one of those weird numbers because it actually contains a number of square roots within it. Okay, so think about this. We know that 9 times 8, and it contains factors of perfect squares, and we certainly know that 9 times 8 is one of those perfect square factors, but also consider that 36 times 2 is also the square root of 72, right? And so one form that we could write this in would be square root of 9 times square root of 8, which would be 3 roots of 8. Now the other one, we know that this would be the square root of 36 times the square root of 2, which would be 6 roots of 2. And you might be thinking, okay, well, which one's the simplified version? Well, it's actually going to be this one, and here's why. Because 8 is 4 times 2. Right? And we know that we could rewrite that as 3 root 4 root 2, or 3 times 2 root 2, or 6 roots of 2, which is the exact same thing as what we just got. Whenever you have a choice of simplifying, you always want to pick the higher of the 2 possible square roots if there are 2 perfect squares. Okay, so Just think about that when you're simplifying, all right, if it's all possible, all right? So another thing that we have to do is we have to approximate this. So on our graphing calculator, let me go ahead and say this is the square root of 72. And just to check to make sure that 6 roots of 2 is the same thing, it should be 8.49 if we were to round that to 2 decimal places effectively. But regardless, it's the same decimal. Okay, so 8.49. So this is going to be approximately 8.49, rounded 2 decimal places. And then the last thing we need to do is we just need to find the midpoint. Remember, for our midpoint, that's going to be x1 plus x2. So that's negative root 37 divided by, or plus 0. So negative root 37 plus 0, divide 2, comma, 0 plus root 35. Right, divide by 2. And so ultimately, as best as we can get it, that's going to be root 37 over 2, comma, root 35 over 2. And that's going to be our midpoint. Right? So those are 3 examples of being able to find the midpoint as well as the distance between 2 line segments. Okay, so we need those to be able to do the next sorts of problems, which are all going to be circle problems. So in our next set of videos, in fact, all the videos for the remainder of the section, they're going to be focused on the equations of circles and being able to sketch those equations on a Cartesian plane.